All right, let's take a look at this example. We have g of x equals x squared minus x minus 12 all over x minus 2. I want to be able to graph this rational function, and in order to graph it, I want to answer these series of questions. So first thing, let's look at the domain. When we look at the domain, we want to figure out what values of x are going to make 0 in the denominator. So if my denominator is x minus 2, that means if x equals positive 2, that's going to make my denominator 0. So my domain is going to be everything but 2. And I'm going to go ahead and write that in interval notation. So everything but 2. Since I know 2 is my issue, that's also where I have my vertical asymptote. The vertical asymptote is whatever makes 0 in the denominator. So that means I'm going to have the line x equals 2. You have to give that x equals part because it's a vertical line. You can never have an x value of 2 for this particular rational function. Now looking at horizontal or oblique asymptotes, you want to compare the degree of the numerator and the denominator. The degree in the numerator is 2. The degree in the denominator is 1. I have a bigger degree up top than I do on the bottom. So the bigger the, since I have a bigger degree on the top, that means I need to do long division to figure out where my oblique asymptote is going to be. So I'm going to have some kind of slant asymptote. It's going to be some kind of, slanted diagonal line, and we're going to figure out where that's at. So off to the side, we can go ahead and do, in this case, we can do synthetic division because I have a linear factor on bottom. So if x minus 2 is what I'm dividing by, that means positive 2 is what I'm going to be using for my synthetic division. It's what makes 0 for that factor. And then check your coefficients. I have 1 for my x squared, -1 for my x, and -12. And notice I'm not missing any of my terms. I have an x squared, I have an x, and then I have a degree 0 term. So I can just pull those coefficients and do some synthetic division off to the side. Drop the 1 down, 2 times 1, -1 plus 2 is 1, 2 times 1 is 2, that gives me -10. So what I have left over here is my remainder. So if I started with an x squared, that means this term right here is going to be just an x. So that means I have x, and then I just go down the line, plus 1, and then my remainder is -10 over whatever it is I'm dividing by, so over x minus 2. This is my remainder. Now, this is the exact same equation right here as what I started with. I just have done the division on it. And this piece, this x plus 1, gives me the equation for my oblique or slant asymptote. The -10 over x minus 2 doesn't have an effect overall on the graph. Think about if you were to plug in really large x values, -10 divided by, say, infinity is going to be 0. So as x gets really, really big, this piece goes to 0 and doesn't have an overall effect on our graph. So we're going to have an oblique asymptote at y equals x plus 1. As far as holes go for our graph, we're going to see if we have any of the same factors in the numerator and denominator. Since the numerator is not factored, I'm going to go ahead and factor. So I need to multiply to -12 and add to -1. So x minus 4 and x plus 3 are going to be my factors. And I don't have any of the same factors here. I have an x minus 4 and an x plus 3 up top. I have an x minus 2 on bottom. Since I don't have the same factors on top and bottom, that means I don't have any holes in my graph. So we'll just say none. For my x-intercept, let's go ahead and plug in y equals 0 and solve this equation for x. Since I have this denominator here, I might as well go ahead and multiply both sides by the denominator. And what's going to happen here, I have an x minus 2 on top and bottom, so those factors are going to cancel. And what I have left is 0 on the left, because 0 times anything is 0, And then on the right, I have x squared minus x minus 12. And so I'm left solving this equation. Well, I already know what this factored form is, so I might as well go ahead and write that in factored form because we did that to help us figure out if we had any holes in our graph. And now we can pretty quickly and easily figure out what's going to make 0 here. If x equals positive 4, I get 0, and if x equals negative 3, I also get 0. So those are going to be my two x-intercepts. My y-intercept, I'll kind of separate that out. My y-intercept is when x equals 0. So wherever there's a 0, let's go ahead and plug in, or wherever there's an x, let's go ahead and plug in 0 and see what we get. This would be negative 12 over negative 2. So that means our y-intercept is at 6. I have pretty good amount of information right now. So I'm going to go ahead and sketch some axes off to the side. And let's fill in this information. I have a vertical asymptote when x equals 2. So I'm going to go ahead and do a dashed vertical line for all x values equaling 2. And we can go ahead and label that line. We have an oblique asymptote when y equals x plus 1. So this is just a linear equation right here. This means I have a slope of 1 over 1 because I have 1x. Just think of this as y equals mx plus b. And the y-intercept of this line is 1. So start at 1, and then we're just going to go up 1 over 1. Up 1 over 1. And we can sketch in this slant asymptote. Okay, so my graph is going to follow these two asymptotes. Let's go ahead and plot our intercepts. We had an x-intercept of positive 4 and an x-intercept of negative 3 and a y-intercept of 6. 1, 2, 3, 4, 5, 6. Again, just kind of a rough sketch right here of my graph. And what's going to happen here is when I sketch in this picture, this bottom piece, I can kind of already tell with where these intercepts are going to be. This bottom piece is going to follow this slant asymptote, hit my intercepts, and then remember, we've got this vertical asymptote here, so it's just going to kind of head up to the top there. So that's about what my left side of my graph looks like. The right side of my graph, again, it cannot cross this vertical asymptote. You can never cross that vertical asymptote. It's going to go through, oops, I missed my x-intercept, and then it's going to kind of follow that slant asymptote. If you want to check, you can always turn on your calculator, go to your y equals, and we can type in this function. And you can look at your picture. So that looks pretty good. The other thing that's kind of cool is you can go to your y equals and go to your y2 and actually type in what your slant asymptote equation is, and you can see that the graph is just kind of hugging that slant asymptote. Down here, when x gets really, really small in the negative direction, it's hugging it, and then as x gets really, really big, it's hugging it. And then you can see at that line x equals 2, we have our vertical asymptote.